And it's not really, and I'm recording now, yes.
So, like, no, there's nothing.
Oh, no.
Chapter 2 or 3?
This is still chapter 2. We are in 2.5 now, okay? It's not that you have to know the names. Give it a second. You don't have to know the names of the theorems, but you do have to know what they do and how to use them, all right? And these are really two theorems that you already know. You just don't know that you know. It says fundamental theorem. Okay? So the fundamental theorem of algebra says, and it's actually of algebra, if I have a polynomial, let's say I have 5x to the 4th tell me some things that you know about this before I tell you what the fundamental theorem is.
It is a factor.
Keep going. Come on, y'all. Tell me anything you know about it. It's a polynomial. What else do you know about it? Tell me specifically about this polynomial. It's missing an x squared. Okay. What else do you know? Somebody just said that what I wanted you to say. What'd you say? Did you say it? Did you say it? I can't hear where things come from. I knew it was a quiet little girl voice, but I couldn't hear where it came from. It has a degree of 4. Right? That comes from the highest exponent. Tell me what the degree of 4 tells us. Tell me some things that it tells me. We talked about this several times. Both ends are going in the same direction. You're absolutely right. And that's going to come into play in just a minute. Both ends, same direction. What else do you know? You're on it today. Can't be more than 4 zeros. Okay? There is 4 or less real zeros. And by real zeros, I'm talking about places that it's crossing the x-axis. Okay? What the fundamental theorem of algebra says is, yes, there might be no more than 4 real zeros, but there are in reality exactly 4 zeros altogether, real and imaginary. Okay, so think about a quadratic. Okay, and maybe that quadratic looks like this. That has no real zeros, right? Right, thank you. Why does it have no real zeros? It doesn't cross the x-axis. But it does have a power of 2, right? The degree is 2 because it's a quadratic. Yeah. But it still has 2 zeros. It's just that in this case, these zeros would be imaginary. Okay? Does that make sense to everybody? And we talked about those 2 imaginary zeros, right? Because it's never crossing the x-axis. Okay, now I'm going to build on this just a little bit, okay? I want you to think back about the zeros. If I know that, let's say I have this quadratic. That should be at 0. Pretend like that's at 0. How many real zeros does this one have? 2, right? What are those 2 zeros? We all agree with that? Would you then agree that I could write the equation of this parabola based just on the zeros? How? If you have zeros, you also have what? Okay, what else do you have? Factors, right? Because we know that if we have zeros, in turn we have factors, and if we have factors, we have zeros. So tell me one of the factors of this quadratic. Factor meaning like this. What is it? Somebody said it, I think. X minus 3. We're going to do this one first because it's easiest to see. Do you see why?
Yeah.
Right? That's a factor. What's the other factor? Which is just x, right? So essentially what I could do is I could write the equation based strictly off of the factors, okay, or the zeros. This is what we call linear factorization, and it's a big fancy word for just using the factors and the zeros to write the equation.
What's linear factorization?
Using the zeros and the factors to write the equation. Yes, I'm fixing to show you an example. Okay, let's say I told you, this is an example, that f of x equals x minus 2i and x plus 2i. Tell me some things you know. They're imaginary. You see the imaginary in there right off, right? What does that tell you? They're not going to touch the x-axis, right? Because these zeros are what? X equals 2i and negative 2i. Do we all agree with that? Can you put this function in standard form? How? Y'all can do this. What's standard form mean? It's in descending order of the exponents, right? I need to get it pieced out instead of just the parentheses. So what do I need to do that? Distribute. You're exactly right.
Please excuse the interruption. Just an announcement reminding those who are scheduled.
So here's what we're going to do. We're going to take this and we're going to distribute through. Okay? Let's do it. And I gave you this one to start with for a particular reason. You'll see why in just a minute. All right. X squared, that's exactly right. Plus 2ix. Just write it together. Don't let it bother you that it's multiple variables. Minus 2ix. What now? Close. 2 times 2, 4i squared. Now here's where you have to rewind back just a little bit. I've got an I squared in there. Tell me what that means. Cancels out and becomes what? What does I squared do to a number? You're close.
Is it a real number?
It does make it into a real number, but what kind of real number? What happens? So what are you doing?
Adding 4.
Because what does I squared really equal? Close. Negative 1. Anytime I squared is hooked to a number, okay? Think back when we did those imaginary numbers. I is the square root of negative 1. So I squared is negative 1. So the only thing it does is when it's hooked to a number, it drops off and changes the sign. Okay? Anytime I squared is hooked to a number. That's going to be crucial for this section. All right, so look what happens here. This is where the magic happens. X squared, 2ix, and negative 2ix is what? They cancel. Plus 4. Now, think about this graphically for just a minute. We all agree it's a quadratic? Mm-hmm. Which way does it open, up or down? Up, right? Because it's positive. What's the y-intercept? 4. So if the y-intercept is at 4 and it's opening up, it's going to be something like that, right? Guess what? It never crossed the x-axis. It doesn't have any zeros. Why does it not have any zeros? Because the zeros are imaginary. Okay? Are y'all with me on that?
Macy is distracting me.
I want you to look at the two factors that we multiplied together. What do you notice about those two factors? The only difference is exactly what I wanted you to say. The only difference in those two factors is the sign in the middle, right? They're opposites.
Right.
The only difference in those two factors is the sign in the middle that I circled in purple there. Okay? That is the only difference. What happened? I started with, those are called complex numbers because they've got a real part and an imaginary part. You remember that from Algebra 2? We did it a little bit too. All right. So I got a real number part and an imaginary number part. I've got two complex numbers that look exactly the same, but the sign in the middles are changed. Okay? Those are special. Those are called conjugates of each other. Y'all remember complex conjugates? What happens when you multiply conjugates together, complex conjugates? You start with imaginary, what do you end up with? Real. Okay? That's crucial to get rid of the imaginary part, and that's what we're going to do as we write equations, okay? So here's what I need you to take away from that. This is theorem number 2. This is the complex conjugate zeros. I'm going to just put THM. Okay? And what it says, and I'm just going to do this in easy to understand words. If you have a complex zero, so a real number with an imaginary number, or even just an imaginary number with zero being the real part. If you have a complex zero, then the conjugate, and I'm going to put in parentheses, change middle sign, is also a zero. And I'll give you a second to catch up on that before. So let's say that I told you that a function had a zero of 2 plus 3i. Then you must know that what else is a zero? 2 minus 3i. Does that make sense? Okay. So here's what we're going to do. I'm going to give you a list of zeros. You're going to have to write the equation. Okay. So what we're going to have to do is we're going to have to take the zeros, we're going to have to make factors out of them, and multiply together. And some of these multiplies are going to get long. You might feel like you're getting bogged down in them. But listen, the consensus this morning was the concept is super easy, the work is super long, and that is very true. Okay, it's going to be a lot of tedious multiplying, but at the end it's just multiplying. Okay, keep that in mind as we go. We're going to do distributing like off the charts. No. All right, so let me give you steps before I do it to write the equation. The first thing we're going to do is we're going to write the factors with all real zeros. Those are easy, right? If I said 2 and 3 are zeros, then the factors would be x minus 2 and x minus 3. It's just x minus whatever that zero is. But then we need to write the factors with the complex zeros. And for every complex zero, you have to include its conjugate as well. Okay, meaning change the sign. So then I'll have to write factors with complex conjugate zeros. Like, oh my gosh, right? If I have two real zeros and one complex zero, then I also have the complex conjugate zero. That's 4 factors that I have to multiply together.
Does complex conjugate zeros mean?
Change the sign in the middle. And then lastly, like I said, we are going to multiply out. But make yourself a note, because we never want to do no more than 2, bless you, at a time. Okay? Never more than 2 at a time. Let's say that I told you that a polynomial has the zeros of -3, 4, and 2 minus I. And I said, those are all the zeros. Write the equation of the polynomial. Now, remember what I told you. Don't freak out on me when we do this. It's going to be a lot of multiplying, okay? All right. We're going to write the factors of the real zeros first. I'm just putting f of x equals. Give me the first factor. X plus 3. And x minus 4. All right. Now we got to do the imaginary numbers or the complex numbers, right? So what's it going to be? X minus 2 minus I. Right? Remember, a 0, x minus a 0 is a factor. That's what we learned in 2-4, right? You take the 0, x minus the 0 is a factor. That's that factor theorem. But if I include a complex, I have to also include the, come on y'all, conjugate, right? I know, everybody's just going, you're waiting on me. Okay, so if I have a complex, I also have to have a complex conjugate 0, okay? So this is, thank you, that's the McGee slide. So this is going to be 2 plus I instead of 2 minus I, but I'm going to set it up the same way. Okay? X minus 2 plus I.
So why did you put the 2 minus I?
I have to do the complex and then I have to do the conjugate. All right. So this is where it all fell apart in first block because they didn't like the way that I multiplied through. So we're going to multiply through a little differently. Yeah. Huh?
You write all of that, and then if there's an imaginary, you write the opposite of it.
Yes. So every imaginary 0 is actually going to have 2 zeros that you're going to have to account for. What you mean?
You would multiply x times.
I am going to multiply these 2 together, and then I'm going to multiply these 2 together, and then I'm going to put them together. Yeah. Yeah. I'm going to clean it up first, and I'm going to show you how to do it. Yeah.
The only time we can like the 2 minus and 2 plus is when they're
Yes. Yes. Correct. Correct. Now, before we multiply this out, what do you think the degree is going to be? 4. Even though I was only given 3 zeros to start with, because every imaginary has 2, it's going to give me the 4. And you see the 4 factors there, right? All right, so I find it easiest if you multiply the real zeros factors together first and simplify, and then the imaginary zeros together and simplify, and then we'll put the 2 of them together, okay? All right, let's look first. Let's just concentrate on those first 2 on the left first. That is just a simple FOIL, yes?
Yes.
Okay, so we get x squared minus 4x plus 3x minus 12. Now I'm going to assume everybody in here can do that, no problem. Is that a good assumption?
Yes.
Okay. X squared minus x minus 12. That is what those first 2 parentheses simplify down to whenever I multiply. Everybody okay? All right. Now what I'm going to do, before I start distributing and multiplying, I'm going to clean these up a little bit. I'm going to make this x minus 2 plus I, right? Because this is a negative for both of them. And then x minus 2 minus I. So I'm going to get rid of those parentheses is what I'm doing. Now, this is a little more complicated. Well, this is a lot more complicated than just a FOIL because there's 3 terms in each one, right? So here we go. Just start with the first and work your way. Don't get overwhelmed with it. Take it a term at a time, okay? Start with the x and distribute through to all these. What is x times x? What is x times negative 2? And then x times negative I. Negative ix. Okay, don't let it intimidate you just because it looks long. Okay, now do the negative 2 through. Okay, negative 2x. Negative 2 times negative 2. And then negative 2 times negative I. Okay, last one. Ix. Negative 2I. Squared, because it's I times I, right? All right, let's keep looking at the white part, okay? Tell me what you see that you can simplify right off.
The 2 i's.
The
Plus 2 I minus 2 I.
the what?
The plus 2 I minus 2 I.
Plus 2I and minus 2I. Those cancel. You're absolutely right. How about this negative I squared on the end?
Negative.
That becomes what? Positive 1. Okay. What else do you see that cancels before I move on? Negative ix and positive ix. Remember what happens when we multiply complex conjugates together? All the i's go away. Makes it look not so bad anymore, right? So this becomes x squared minus 4x plus 5. Who would have thought that this would multiply out to that? But I'm still not done, and why am I not done? I got that other one that I did in the very beginning, right? Holy cow. I'm going to put with this trinomial here. Now I'm going to multiply through. Ready? Oh. I know y'all are excited about doing this. 3 terms again, 3 and 3. All right, let's go through it together. X to the 4th.
Minus 4x to the 3rd. Plus 5x squared.
And what I do when I'm doing big polynomials like this is I'll scratch it out as soon as I get done with it so it doesn't confuse me so I know what's left to distribute. Now what I'm doing is I'm taking a negative x to everything here. Negative x cubed plus 4x squared because I got a negative times a negative minus 5x. I'm done with that term, so I scratch that one out. Okay. Now the next one, minus 12x squared plus 48x minus 60.
60.
Okay, so now clean it up. Put your like terms together.
Well, x4 isn't going to be this.
So x to the 4th minus 4x cubed minus 1x cubed would be negative 5x cubed. I'm just gathering the like terms.
Negative 4x to the... No, 5.
9 minus 12. -3. -5 and 48 would be 43. That was a lot of work, but do you agree that the work itself is not that hard? It's just long and tedious. Did I do something wrong, Maddie?
Yeah, 5x is supposed to be a square, isn't
Where? Where'd I mess up? Where'd I mess up?
it? 5x is supposed to be a cube.
Yeah, it is, because it's an x and an x squared.
It's a -12x squared.
5
plus
isn't an
5x.
x. 5 isn't an x. It's x squared minus 4x.
Should be x to the 4th minus 5x cubed minus 3x squared plus 43x minus 60. That's right.
Yeah,
How
because it's a negative x squared, a negative x cubed, and a negative 4x.
Oh, yeah, you had to combine those two cubes. You had, see that second term is negative 4x cubed, and then this one is negative x cubed. So negative 4x cubed minus x cubed would be negative 5x cubed. Did you distribute the same way we did? Did you start with the first?
That'll be 4x to the power 4 plus 4x cubed. Guys multiply negative x times the negative 4x.
Video